Hello and good morning to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss about the architecture of 8086 microprocessor. As we all know, 8086 microprocessor has two functional units. These functional units are the execution unit and the bus interface unit. The execution unit is responsible for letting the BIU know from where the instruction and the data is to be fetched. It is responsible for decoding the instruction and it's responsible for execution of the instruction. Execution unit has in it the general purpose registers, the pointer registers and the index registers. It also has in it the temporary register, the arithmetic logical unit, the flag register and the EU control logic. There are four general purpose registers, namely AX, BX, CX, and DX, that can be used in order to perform 16-bit operation, or it can also be used in order to perform 8-bit operation, where we have AH, AL, BH, BL, CH, CL, DH, DL as representations of AX, BX, CX, and DX respectively. Then we have the pointer registers. We have the stack pointer register and the base pointer register. We have the source index register and the destination index register. So all of these four registers, which are stack pointer, base pointer, source index and destination index, these are all 16-bit registers. Then we have the temporary registers that are used by the ALU while performing arithmetic and logical operation. Then we have the 8086 ALU that is capable of performing both 16-bit as well as 8-bit arithmetic and logical operations. Then we have the flag register, which keeps track of the various flags. We have learned in the previous class that the flag register is of 16-bit length, out of which 9 bits are active and 7 bits are left unused. Out of the active 9 bits, 6 bits are used in order to reflect control or condition. 6 bits are used in order to reflect status or condition, whereas 3 bits are used in order to reflect control. Then we have the EU control system. Likewise, in case of bus interface unit, we have the segment register and we have the instruction pointer. Segment register along with the associated offset is used in order to create 20-bit representation of the address. Then we have the instruction queue. Instruction queue is used in order to store the prefetched instruction bytes that are given to the execution unit in sequence in order to perform operation. We have also learned in the previous class that with the use of instruction queue, we can enhance the performance of the microprocessor or increase the instruction throughput. But it's to be understood that the use of instruction queue does not reduce the total amount of time required for executing an instruction. Now, in addition to these components, we have the BIU bus control logic. Now, these are the various components present in the execution unit and the bus interface unit of the 8086 microprocessor. Now, let us discuss in detail the functions or the roles and responsibilities of each of these identified units. Now, as we have learned, 8086 microprocessor CPU is divided into two independent functional units, which are bus interface unit and the execution unit. Now, the bus interface unit performs the following functions. The first function is to fetch instruction and data from memory. This is in the direction of the execution unit. So, depending upon the requirement of the execution unit, the BIU will be fetching the instruction or data from memory. It will write data to the memory, it will read data from the port and write data into the port. So these are the set of functions that BIU performs. Now let us discuss instruction queue. As we have already discussed instruction queue in detail in the previous class, we will be just panning through the description. So instruction queue is used in order to increase the execution speed. Here, BIU fetches as many as 6 instruction bytes ahead of time from the memory, which will be given to the EU one by one in order to perform operation. So all 6 bytes are then held in a first in, first out 6-byte register called as instruction queue. Then all of these bytes are given to the execution unit one by one in order to perform operation. Now, the prefetching operation of BIU may be in parallel with the execution operation of EU, which improves the overall execution speed of the instruction. So this is the very purpose for which the instruction queue is being used. Then we have the bus control logic. Now, as we all know, binary information in case of computer system communicates among the various components with the help of connected wires known as buses. So there are 3 different types of buses in a microprocessor based system: the address bus, the data bus, and the control bus. The address bus is a unidirectional bus that is capable of holding address of the memory location to or from where the data is to be read or written to. So depending upon the control signals that are there in the control bus, CPU decides whether to read from or write into the memory location. So signals on the control bus tells the CPU whether a read or write operation to that memory cell is required. Now, as we all know, in case of 8086 microprocessor, there are 20 address lines using which we can address 2 to the power 20 address location. That is 1 megabyte of address location. Now, as we further know that in case of 8086, the overall memory of the computer system is partitioned into logical segments where each segment is of 64 kilobyte. So the address lines are capable of holding address values of the memory location from where the data is to be read or written to. Now, likewise, data bus. So 8086 microprocessor has a 16-bit data bus which is bidirectional. This implies that it can be used in order to transfer data to or from the CPU. So it can transfer data in both byte and word to and from the CPU and memory. Now, likewise, we have the control bus. So control bus is used in order to carry out various synchronization activity to decide whether read or write is to be performed. So these are in a nutshell the role of the address bus, the data bus, and the control bus. Now, let us move on to the activities that are performed by the execution unit. The functions that are performed by execution unit, the first one is to let the BIU know from where the instruction and data is to be fetched. So this is the primary activity of the execution unit, to let the BIU know from where the data and the instruction is to be fetched. Then to decode the instruction and subsequently to execute the instruction. So the execution unit of 8086 microprocessor has a 16-bit arithmetic logical unit which can perform arithmetic logical operation both on 8-bit as well as 16-bit data. So this is to be understood. The 16-bit ALU of 8086 microprocessor is capable of performing both 8-bit as well as 16-bit arithmetic logical operation. Now the general purpose registers. Now, there are 4 general purpose registers, namely AX, BX, CX, and DX, which can be used as 16-bit registers or it can be used as 8-bit register depending upon the requirement of the operation. So we have AH, AL, BH, BL, CH, CL, and DH, DL as an 8-bit representation of AX, BX, CX, and DX respectively. Now AX register, which is also known as accumulator, it is used in order to store operands during arithmetic and logical operations. So this we have already learned. AX register, which is also known as accumulator, it is used in order to store operands during arithmetic, logical and data transfer operations. Likewise, BX register, this is known as base register. It is used as a address register. It holds the starting base location of memory region within a data segment. So it is used to point to a data in a memory location. Likewise, CX register, it is also called as the counter register. It is used in order to hold counter value while performing looping operation. And in addition to that, it's also used in string operation and shift oblique rotate instructions. Now, likewise, we have a DX register. It's known as data register. It is used in order to hold IO port address while performing or while executing IO instruction. It is also used in division and multiplication instructions. So this we have already learned in the previous class. So we have 4 general purpose register that can be used as 16-bit registers, or it can be used as 8-bit register depending upon the requirement. Then we have the segment register. So this also we have learned. There are 4 segment registers: code segment, data segment, stack segment and extra segment register. These registers are 16-bit in length and are used in order to store the base address of the respective segment. So code segment register is used in order to store the base address of the code segment. Data segment register is used in order to store the base address of the data segment. Stack segment is used in order to store the base address of the stack segment. Likewise, extra segment is used in order to store the base address of the extra segment. Associated with each of these segment registers, we have the offset, using which we create displacement in order to access specific byte in the respective segment. So we have IP, which is used in correlation with or in conjunction with code segment. We have BX, SI, and DI used in conjunction with data segment register. We have SP and BP used in conjunction with stack segment register. As likewise, we have BX, SI, and DI, which is used in conjunction with the extra segment register. So these segment registers basically hold the base address of the respective segments. Then we have the flag register of 8086 microprocessor. We have learned that 8086 microprocessor has a 16-bit flag register. Out of this 16-bit, 9 bits are active and 7 bits are left unused. Out of the active 9 bits, 6 bits are used in order to reflect condition or status, whereas 3 bits are used in order to reflect the control. The 6 conditional flags or status flags are overflow flag, zero flag, sign flag, carry flag, auxiliary carry, and parity flag, whereas the 3 control flags are direction flag, interrupt flag, and trap flag. Now let us discuss the flags in a little detailed manner. So we have the conditional flags. So we have 6 conditional flags: carry, auxiliary carry flag, parity flag, zero flag, and sign flag. So carry flag, so this flag indicates an overflow condition for unsigned integer arithmetic. It is also used in multi-precision arithmetic. So if there is a carry in case of addition and borrow in case of subtraction, then this particular flag is set. Now auxiliary flag. So auxiliary flag is a flag that is set if there is a carry from bit 3 in case of addition and borrow from bit 3 in case of subtraction. So this is the situation where the auxiliary flag will be set. Now parity flag. So parity flag is a flag that is set if there are even number of ones in the lower order byte of the result. So if there are even number of ones in the lower byte order of the lower byte of the result, then parity flag is set. Likewise, zero flag. So zero flag is set if the result of the arithmetic and logical operation results in zero. Now sign flag is set in situation if the MSB is 1. That means, so when MSB will be set to 1 is when the result will be negative. So if the result of an operation is negative, the sign flag is set. So in sign magnitude format, the sign of a number is indicated by the MSB bit. So this is understood. This is well known that the MSB will be representing the sign of the signed value. So if the sign bit is 1, then it means that the value is negative. So if the value is negative, the sign flag will be set. Likewise, we have the overflow flag. So it occurs when signed numbers are added or subtracted, and overflow flag indicates that the result has exceeded the capacity of the machine. So if there is if there is overflow from the 15th or the 7th bit in case of 16 or 8-bit operation, then the overflow flag will be set. Now likewise, we have the three control flags. The control flags are the trap flag, the interrupt flag, and the direction flag. Now, as we have already learned the utilities of these flags in the previous class, so we will not be going through it in detail, but just remember that these flags are control flags that are used in order to keep track of the trap or the interrupt and the direction in case of string operations. So trap flag, it is used for single step control. It allows you to execute one instruction or program at a time for debugging. When trap flag is set, program can be run in a single step mode. Likewise, interrupt flag, it is an interrupt enable disable flag. If it is set, the maskable interrupt of 8086 is enabled, and if it is reset, the interrupt is disabled. It can be set by executing instruction and can be cleared by executing. So there are a set of instructions that can be used in order to enable or disable it. Then we have direction flag. So direction flag, it is used in string operation. If it is set, string bytes are accessed from higher memory address to lower memory address, and if it is reset, string bytes are accessed from lower memory address to higher memory address. So this we have learned in the previous class. So in today's class, we have learned about the architecture of 8086 microprocessor. We have learned about the various functional units. We have learned about the composition of each of the functional units, and we have learned about the responsibilities of each of the functional units in detail. We have also learned about the role of the instruction queue, the bus control logic, the execution unit, the use of general purpose register, the segment register, and the flag register. So this ends up today's class. Thank you very much and have a very good day.